So let me explain a little bit about the sound intensity level and decibel. So how we usually calculate the intensity of sound is by comparing the intensity of sound with a specific reference sound intensity level. In a physical definition, sound intensity level is amount of the energy per unit space. I mean here two-dimensional space. And then the range of the sound intensity level that our ear can detect are really vast. For example, it can detect from like a 10 to the minus 12 watt per meter square to 10 to the zeros, like a 1 watt per meter square. Let's assume that that is the loudest sound intensity level that our ear can detect. So this means that the quietest sounds that our ear can detect are extremely small, which means you have 12 zeros after the dot. So this is kind of not very convenient and efficient. So for measuring sound intensity level, we use a logarithmic levels because to reduce the vast range into the more easily manipulatable levels. So how we measure the sound intensity level is usually by comparing our sound intensity level with the reference sound intensity level. But if your sound intensity level is a 10 to the zeros over 10 to the minus 12s, it's like this one is a 10 to the 12s larger than the reference sound intensity level. So if we put a logarithm there, this becomes just 12. So this is 12 times larger than this one if we express this in a logarithmic unit. So this is the definition of the bell. So the bell is a log 10 I over IR. So which means 10 bells means that our sound intensity level is 10 to the 10th larger than the reference sound intensity level. And one bell means log 10 I over IR, so that it means our sound intensity level is 10 times larger than the reference sound intensity level, which is still large because just increasing one bell, our sound intensity level is already like 10 times larger than the reference sound intensity level. So what we do is we use a decibel. So 1 decibel is 10 multiplied by I divided by IR. I added this short recording to explain about the relationship between bell and decibel. So decibel is 1 over 10 over bell, which means 10 times smaller than the bell. So the dB is 10 multiplied by log 10 I divided by IR, which means dB over 10 is log I divided by IR. So this is the bell. So to get the same amount of the bell, I mean the intensity relationship, when you compare with the sound intensity of the reference, you need to increase 10 decibel to get the same amount of the 1 bell, because you put the 10 here, you get the 1, and this is the definition of the 1 bell. So by using the decibel, you can more meticulously adjust the sound intensity level and measure those sound intensity level. And decibel is good to use because it is close to the smallest amount of intensity change that our ear can detect, which is called as a just noticeable difference. 1 decibel means that 10 to the 1 over 10, which is something like a 1 point, let's see, 208. Okay. So by using the decibel, we can kind of more meticulously manipulate the sound intensity level, because 1 decibel increase, the increment of the sound intensity level 1.258 times larger than the sound intensity level of the reference. So let's see how we can use this equation for calculating the decibel changes and the actual sound intensity level changes. So here is the problem. dB changes from 1 dB to 5 dB. So 1 dB to 5 dB. And then as we know, the equation is a dB is a 10 log 10 I over IR. And then 1 dB is a 10 log 10 I over IR, which means I divided by IR is 10 to the 1 over 10. And then what is the 5 dB? 5 dB is our new I divided by IR is 10 to the 5 over 10. So what would be the sound intensity level differences between our new I and then I? Let's write new I and then old I. So let's calculate that. So I new over IR divided by I old divided by IR is 10 over 5 over 10 over 10 over 1 over 10. 10 to the 5 over 10 over 10 to the 1 over 10. So we can see our new sound intensity level when compared with our old sound intensity level would be 10 to the 4 over 10, right? So this means our intensity level is changed to when compared with the old sound intensity level, it becomes 2.51, which is the value of this one. So this is one way how you calculate the actual sound intensity level changes by using the decibel thing. And the another way is we know that our decibel difference is 4. 4 is 10 over log I new over I old. So this is another way, because we know that the definition of a decibel is a comparison between two different sound intensity level. So the differences between the new sound intensity level and old sound intensity level can be calculated by just plotting those values into the decibel equation, because it's the definition of the decibel. So we now know that new sound intensity level over old sound intensity level is 10 to the 4 over 10, which is 2.51. So this is how you calculate the decibel, and then you can clearly see the meaning of the decibel, which represent the ratio between the sound intensity level that you want to measure when compared to the reference sound intensity level. By the way, we usually use the reference sound intensity level as a 10 to the minus 12 watt per meter square, IR. But this is really not a mandatory thing that you need to remember, because decibel is always relative. So you just compare like this way. If you increase the decibel like a 10 by 10, then your sound intensity level will be 10 log 10 I new over I old, and this means your new sound intensity level is 10 to the 1, 10 times larger than the old sound intensity level. So by increasing decibel by 10, it becomes like a 10 times larger than the old sound intensity level. If it is like a 2, then it becomes like a 1 over 5, 10 to the 1 over 5 times larger than the old sound intensity level. Sorry, you are not looking at this. So that's the definition of decibel and sound intensity level. But please remember that decibel also can be used not only for the sound intensity level, but also sound pressure level. So there are multiple units that you can use to measure the sound intensities in the acoustic physics. Not only the sound intensity level, but also you can use a sound pressure level to measure the amplitude of the sound.